Have you ever pictured the ultimate World War I dogfight?
Oh, I think everyone has that exact image in their head.
Right. Like if you close your eyes right now, there is a very good chance you are picturing this bright red triplane darting through the clouds.
You're picturing the legendary Fokker Dr.I.
Exactly. Flown by Manfred von Richthofen, the Red Baron. It is, it's arguably the absolute icon of early aviation.
It really is.
But what if that ultimate symbol of aerial dominance was actually a deeply flawed, terribly rushed prototype, like a machine held together by literal varnish, shoddy materials, and just a whole lot of luck?
Well, what's fascinating here is how the perception of this aircraft has completely overshadowed its physical reality. We remember the myth, the striking silhouette of those three stacked wings, the famous pilots.
Yeah.
But if you look closely at the engineering reality, you find a story of profound compromise.
So, welcome to today's deep dive. Our mission today is to look past the towering myth of the Fokker triplane. And we are going right to the source material today.
Which is incredibly detailed.
It is. We're using the aircraft's Wikipedia page as our sole guide to unpack the chaotic research and development, the terrifying structural flaws, and the bizarre operational history of this machine. We want to discover why being famous in the history books does not always translate to being fundamentally good.
We're looking at this aircraft as a case study in wartime engineering. It provides a perfect window into what happens when technological innovation isn't driven by careful research, but by sheer panic.
Sheer panic and extreme pressure from the front lines. So let's set the stage and look at the catalyst for that panic.
Right.
In the spring of 1918, the Dr.I and Doctor simply stands for Dreidecker, or triplane, was highly visible. Built by Fokker Flugzeugwerk, it became world famous because Richthofen scored his last 17 victories in it before he was killed.
But despite all that fame, total production was actually incredibly small.
Yeah, they only ever built 320 of them, which is nothing for wartime production.
No.
To understand why that number is so low, we have to look at what the German Air Force, the Luftstreitkräfte, was dealing with a year prior in early 1917.
The overarching issue was that German pilots were suddenly losing control of the skies over the Western Front. A new Allied aircraft had appeared.
The Sopwith Triplane.
Exactly. And the Sopwith wasn't even heavily armed. It only carried a single Vickers machine gun, but its three-wing design gave it incredible agility and a phenomenal rate of climb.
It was just flying circles around the Germans.
It was swiftly outclassing the heavier, twin-gun German Albatross fighters. So the German High Command needed a direct counter, and they needed it immediately.
Okay, let's unpack this. Because the German response to the Sopwith is essentially the ultimate copy my homework moment in early aviation.
It really is.
In April 1917, the aircraft manufacturer Anthony Fokker visits JAST 11 on the front lines. And he actually gets a chance to inspect a captured Sopwith triplane.
Which was a massive stroke of luck for him.
For sure. So after looking it over, he travels back to his factory in Schwerin, walks up to his lead designer, Reinhold Platz, and basically just tells him to build a triplane.
Just build a triplane.
Yes. But he gives Platz absolutely zero technical specifications about the captured Sopwith. Nothing.
It's a staggering lack of direction for a major military contract. Platz is left entirely to his own devices. But, he was a brilliant designer, and he responds by creating a prototype designated the V.4.
Right.
It was a small, rotary-powered triplane featuring a steel tube fuselage. But the most significant feature Platz incorporated was the use of thick cantilever wings.
Let's pause on that term for a second, just to be clear. When you say cantilever wings, you're talking about wings that support their own weight internally.
Exactly.
Because most planes back then looked like a bird cage of external wires holding the wings up.
Precisely. Platz had previously worked on government-mandated collaborations with Hugo Junkers, and Junkers was pioneering internally braced wings.
So no wires.
Right. Instead of a web of external bracing wires that cause massive aerodynamic drag, a cantilever wing relies on deep, strong internal wooden spars to carry the load. It's a much cleaner, more modern aerodynamic design.
But despite that innovation, when the V.4 went up for its initial test flights, it was an absolute nightmare to handle.
The test pilots reported that the control forces were completely unacceptable. The ailerons and the elevators were unbalanced.
Without getting too deep into the weeds, what does an unbalanced aileron actually feel like to a pilot sitting in the cockpit?
Well, without balanced control surfaces, the pilot doesn't have any aerodynamic leverage. When they move the stick to bank the aircraft, they are physically fighting the full, raw force of the wind pushing against that aileron.
That sounds exhausting.
It is. In a dogfight where you are constantly making aggressive split-second maneuvers, an unbalanced system would completely exhaust a pilot's physical strength in a matter of minutes.
So Fokker realizes this exhaustion is a fatal flaw. They don't even submit the V.4 for official military testing.
They knew it would fail.
Right. They pivot straight to a revised prototype called the V.5. And to fix that heavy steering, they introduce horn balance ailerons and elevators.
Right. A horn balance is basically a portion of the control surface that extends forward of the hinge line.
Okay.
When the pilot deflects the aileron, that forward section catches the oncoming air and actually helps push the rest of the surface into position.
Ah, clever.
It uses the air pressure to assist the pilot's movement, making the controls feel incredibly light and responsive.
The V.5 also introduced longer wings. But the most visible change they made, and I love this detail, they added interplane struts, those vertical wooden posts connecting the outer edges of the three wings together.
Yes.
And this is fascinating because those cantilever wings were technically strong enough on their own. They didn't structurally require those struts to hold the wings to the fuselage.
They didn't need them at all. Adding struts meant adding weight and completely negating the low drag advantage of the cantilever design they worked so hard on.
So why do it?
They had to add them because without external bracing, those long wooden wings flexed and bowed dramatically during flight.
Which would be absolutely terrifying to watch if you're the one flying it.
Exactly. Imagine putting your aircraft into a steep dive and watching your wings flap like a bird's.
No, thank you.
It would completely shatter a pilot's confidence in the machine. So the struts were added almost entirely as a psychological band-aid just to stop the visual flexing.
Wow.
And it worked well enough that the military testing body, IDFLIG, ordered 20 pre-production aircraft in July 1917, though they did test one to destruction on the ground just to be sure it wouldn't immediately fall apart.
So after fixing the controls and adding these placebo struts, how did this thing actually perform when it faced enemy fire? Because the first two pre-production models, designated as the FI, are sent straight to combat evaluation in Belgium in late August.
This is exactly where the legend takes root. Manfred von Richthofen takes one up on September 1st. Over the next 2 days, he shoots down 2 enemy aircraft.
Incredible debut.
He immediately writes this glowing report back to the High Command, boldly declaring that the FI is fundamentally superior to the Sopwith Triplane. He essentially demands that fighter squadrons be re-equipped with it as soon as possible.
I mean, you get a 5-star review from the most famous ace of the war. It seems like a massive triumph.
It does.
But here's where it gets really interesting. The combat evaluation phase ends incredibly abruptly. Not because they learned everything they needed to know, but because Richthofen wasn't the only one evaluating those 2 prototypes.
Right.
He handed them off to other elite pilots. And within weeks, in September 1917, the pilots of both of those planes, Kurt Wolff and Werner Voss, who were highly decorated squadron leaders, were shot down and killed in them.
This raises an important question regarding military procurement. You have a brand new aircraft, and within its first weeks of frontline testing, it directly results in the deaths of 2 of your most experienced aces.
Right.
Logically, that should trigger an immediate halt and a massive reevaluation of the entire program.
But the desperation from the high command overrode logic entirely. The orders just keep rolling in. They order 100 in September, another 200 in November. They officially designated the Dr.I, and mass production just ramps up.
Despite the glaring red flags.
Exactly. And their solutions to its operational hazards were borderline comical. For instance, the landing gear design made the plane incredibly tricky to land. It had a severe tendency to ground loop, basically spinning out of control as it touched down, dragging its lower wings in the dirt.
And rather than redesigning the landing gear geometry to actually make the aircraft stable on the runway, the factory simply bolted wooden skids onto the bottom of the lower wingtips.
It was literal duct tape engineering.
They just added bumpers so the wings wouldn't snap when the plane inevitably spun out.
It really underscores how badly they needed these in the air. But we should acknowledge that once it actually got into the air, the Dr.I did offer some incredible advantages. Listen to this quote from Franz Heimer, a pilot who flew with Justice 6.
Sure.
He said, "The triplane was my favorite fighting machine because it had such wonderful flying qualities. I could let myself stunt leaping and rolling and could avoid an enemy by diving with perfect safety."
That praise highlights the one thing the Dr.I did exceptionally well.
Maneuverability.
Exactly. The rudder and elevator controls were highly responsive. But the real secret to its agility, and this is a crucial piece of the engineering puzzle, was its engine. The Dr. I utilized a rotary engine.
And we should clarify the difference there, because a rotary engine is not the same thing as a radial engine, even though they look really similar from the outside.
Right. In a standard radial engine, which is what most later propeller planes use, the engine block is bolted to the airframe and stays completely still while the crankshaft spins the propeller.
Makes sense.
But in a World War I rotary engine, the crankshaft is bolted firmly to the airplane, and the entire engine block, all the cylinders, the spark plugs, the casing spins around it at hundreds of revolutions per minute, taking the propeller with it.
That is a massive amount of spinning metal at the very front of a tiny, lightweight wooden airplane.
It creates immense gyroscopic precession. If you've ever held a spinning bicycle wheel by the axle and tried to tilt it, you feel that bizarre heavy force pushing back against you at an angle.
Yeah, it fikes you.
That's gyroscopic torque. In the Dr. I, that spinning engine mass caused marked directional instability. It desperately wanted to pull to the right.
Which sounds terrible.
While instability is terrible for a passenger plane, for a fighter pilot, it meant the aircraft was incredibly eager to change direction. A skilled pilot could use that gyroscopic torque to execute lightning fast, flat turns to the right that Allied fighters simply couldn't follow.
But relying on that engine came with a massive penalty. While it could outturn anything, it was shockingly slow.
Yes, very slow.
In level flight and in a dive, it could not keep pace with contemporary Allied fighters. It had a great initial climb rate, but once you got up to higher altitudes, the performance just evaporated.
That high-altitude drop-off was a direct result of the specific rotary engine they were using, the Oberursel-Urschuhr. It was a 110-horsepower, 9-cylinder engine, but it wasn't a German design.
It was stolen, essentially.
It was a reverse-engineered clone of a captured French engine, the Laronde 9J. The German manufacturing processes couldn't quite match the original tolerances, resulting in a clone with poor compression. In the thin air at high altitudes, it simply starved for power.
And to make matters worse, the German supply chain doomed those engines to early deaths. Rotary engines run incredibly hot, and they fling their lubricating oil out through the exhaust as they spin.
Very messy engines.
Very. And they required a very specific lubricant that wouldn't break down under those extreme conditions. They needed castor oil.
But due to the Allied naval blockade, Germany was experiencing severe chronic shortages of castor oil, so the military was forced to rely on ersatz lubricants.
Synthetic substitutes.
Or lower quality substitutes. These substitute oils broke down rapidly under the heat and friction of the rotary engine, leading to catastrophic engine seizures, especially during the hot summer of 1918.
So if you're a German pilot, let's look at what you're dealing with. You're flying an airplane that is slower than your enemy, powered by a cloned engine that might seize mid-flight because it's running on fake oil.
It's a grown picture.
And the cockpit experience doesn't make it any better. You have 3 giant wings obstructing your view during takeoff and landing. The cockpit is cramped, built with cheap materials, and then there are the guns.
The armament setup was a major hazard. It carried 2 7.92mm Spandau machine guns mounted directly in front of the cockpit. The gun butts protruded back into the pilot's immediate space, mere inches from their face.
Now remember, this is an airplane that loves to spin out and crash during routine landings.
Exactly. Combined with entirely inadequate crash padding on the cockpit coaming, a standard ground loop could violently throw the pilot forward. Surviving a dogfight only to suffer severe, sometimes fatal head trauma from your own machine guns during landing was a very real threat.
But the landing gear and the engine weren't even the deadliest flaws. The true horror of the Dr. I revealed itself in late October 1917.
The structural failures.
Right. Heinrich Gontermann, the leader of JASTA-15, is performing standard aerobatics when his triplane literally breaks apart in midair. He crashes and dies. Just 2 days later, Gunther Pastor of JASTA-11 is killed when his triplane also disintegrates.
No dogfight, no extreme maneuvers, the wings just collapsed.
Exactly. 2 fatal midair structural failures in 48 hours forced Idfleet to ground every single triplane on the front lines in early November. They convened a Sturz Commission, a crash commission, to investigate why these aircraft were tearing themselves apart.
The commission's findings were a massive embarrassment for Anthony Fokker. They discovered incredibly shoddy construction practices at his factory. The wing structures weren't being properly waterproofed.
Just poor craftsmanship.
Yes. Moisture was seeping into the wings, rotting the wooden structure from the inside out. The wing ribs were literally disintegrating. Under aerodynamic load, the rotting wood would give way, the ailerons would tear off, and the entire wing would catastrophically fail.
Fokker was severely reprimanded. He was forced to immediately improve quality control, meticulously varnishing the wing spars and ribs to seal out moisture.
They strengthened the rib structures and the auxiliary spars.
And Fokker had to implement these modifications on all existing triplanes entirely at his own expense before they were allowed back in the air.
Which is a huge financial hit.
So they varnished the wood, reinforced the ribs, and the planes returned to service by late November. But here is the truly terrifying part of the story. The fixes didn't work.
No, they didn't.
The wings kept failing. In March 1918, Lothar von Richthofen, the Red Baron's brother, experiences a catastrophic failure of his upper wing leading edge during a dogfight. He barely manages to crash land and is severely injured. All the varnish in the world wasn't stopping the wings from breaking.
If we connect this to the bigger picture, we find out that poor factory workmanship was only a symptom. The terminal disease of the Fokker triplane wasn't uncovered until more than a decade after the war.
Long after the plane stopped flying.
Exactly. In 1929, the National Advisory Committee for Aeronautics, NACA, the American organization that eventually became NASA, conducted deep aerodynamic investigations into the Dr.I's design.
What did the NACA wind tunnel tests actually reveal? Because this is the ultimate vindication for those pilots who felt the plane was unsafe.
NACA discovered a fundamental aerodynamic flaw in how lift was distributed across the three wings. In a standard biplane, the aerodynamic load is shared relatively evenly, but the Dr.I had a specific staggered triplane configuration.
Right, the wings were stepped back from top to bottom.
Exactly. The wind tunnel testing proved that the upper wing was operating in clean, undisturbed air, which vastly accelerated the airflow over the middle and lower wings. Because of this aerodynamic interference, the upper wing was carrying a drastically disproportionate amount of the lift.
How disproportionate are we talking?
At high speeds, the upper wing carried a lift coefficient up to 2.55 times higher than the lower wing. It was doing over 2.5 times the aerodynamic work.
That is immense.
It is. When a pilot put the aircraft into a steep dive and pulled up or banked hard in a dogfight, the sheer aerodynamic force focused on that single top wing was staggering.
It just couldn't take it.
It simply wasn't built to handle that uneven load. It didn't matter how well Fokker varnished the wood or reinforced the ribs. Aerodynamically, that upper wing was predisposed to tear itself apart under combat stresses. It was fundamentally doomed by its own design.
It's incredible to think that these pilots were going up every single day in a machine that physics itself had marked for destruction. And the German military eventually realized the triplane was a dead end. Its chronic structural problems, combined with its slow speed, destroyed any chance of large-scale production. Manufacturing officially ended in May 1918, capping the total run at just 320 aircraft.
By the summer of 1918, the Dr.I was being rapidly pulled from frontline service, replaced by the Fokker DVF, which was a vastly superior, structurally sound biplane. The surviving triplanes were relegated to training schools and home defense.
And their fate after the war is genuinely tragic for aviation historians. By the time of the armistice, there were very few left. Only 3 original triplanes are known to have survived the end of the conflict. And sadly, none of them exist today.
It is a profound irony. One of those 3 survivors was serial number 15217. And this was an incredibly historic artifact. It was the very plane Manfred von Richthofen flew to score 3 of his combat victories.
Wow.
It was preserved and put on display at the Zoohaus Museum in Berlin. It survived the entirety of the First World War, only to be completely destroyed by Allied bombing raids during the Second World War.
That's heartbreaking.
A second original, pieced together by Fokker himself in 1932, was destroyed in another bombing raid in 1943. Today, only small fragments, pieces of fabric, a few instruments survive in museums.
Which means that every single Fokker triplane you see flying in an air show today is a replica. The cultural footprint of the Dr.I is so massive that enthusiasts just keep building them from scratch.
Right.
Bits Flugzeugbau famously built 2 full-scale replicas for the 1966 movie The Blue Max.
Oh.
And here's one of my favorite facts from the sources. In 2014, Bruce Dickinson, the lead singer of Iron Maiden, actually bought a Dr.I replica.
Though if you do see one flying today, you'll likely notice it sounds quite different from the historical accounts.
Because of the engine.
Right, because authentic 1910s rotary engines are incredibly scarce and notoriously difficult to maintain. The vast majority of modern airworthy replicas are powered by later radial engines, like the Warner Scarab. You get the vintage look, but with an engine block that safely stays put while the propeller spins.
A bit safer that way.
Definitely. A few purists do manage to source vintage Lerone rotaries, but they are very rare.
So what does this all mean? We started out by picturing the ultimate, iconic dogfighter, the legendary Red Baron commanding the skies in his bright red machine. But the reality we found in the sources is a vastly different story.
It's practically the opposite of the myth.
It is. The Fokker Dr.I is the ultimate historical example of why you should never judge a machine strictly by its paint job or its fame. It was a terrifying, deeply compromised aircraft. It was slow, cramped, powered by a cloned engine running on synthetic oil, and its upper wing was aerodynamically destined to rip itself to shreds.
Yet it's a legend.
Because it achieved that legendary status almost entirely through the sheer unmatched skill and the immense celebrity of the few elite pilots who managed to fly it without dying.
It was a triumph of human skill over catastrophic engineering. And this raises an important question, something for you to mull over after we wrap up today.
Oh, definitely.
This deep dive proves that history has a persistent habit of remembering the bold aesthetic and the famous user, while completely forgetting the deeply flawed engineering hidden beneath the surface. It makes you wonder, what other legendary pieces of technology out there are getting a historical free pass?
I love that question.
Right. Whether it's vintage muscle cars, early classic computers, or famous historical weapons, how many of them are sitting on a cultural pedestal right now, solely because we've collectively forgotten how incredibly terrible they actually were to use?
That is a fantastic thought to leave on. Thank you so much for joining us on this deep dive into the true story of the Fokker Triplane. We hope it gave you a brand new perspective on an aviation legend. Until next time.